Hello everyone, I am Inderjeet Kumar and welcome to this 6-minute dive into sensors and microcontrollers, the heart of IoT devices. Having built projects like Drishti-Nav, blind stick for visually impaired people to navigate them, and a pocket AI voice assistant using Raspberry Pi, I'll show you how these components create smart connected systems whether you are a beginner or a hobbyist. This video will give you a solid foundation for your IoT journey. Let's begin with microcontrollers. A microcontroller is a compact computer on a single chip integrated with CPU, memory, and input output ports. Unlike microprocessor, which power devices like laptop and needed external components. Okay, microcontrollers are self-contained and designed for specific low power tasks. ESP32, for example, is a system on a chip microcontroller with built-in Wi-Fi and Bluetooth make it perfect for IoT. In my Drishti-Nav project, I use a Raspberry Pi, but an ESP32 could similarly process sensor data for obstacle detection or GPS tracking. Microcontrollers, all in one, low power, task specific, and microprocessors, high power, general purpose, needed external components. Okay, understanding IoT sensors. These are the sensors. Here you can see sensors are the eyes and ears of the IoT device, converting real world conditions like distance, sound, and or temperature into digital signals for microcontroller to process. In my Drishti-Nav blind stick, I use ultrasonic sensors to measure distance by sending sound waves and GPS module to track location. My Pocket AI voice assistant relies on microphone to capture voice commands. Sensors vary widely, so let's classify them. Here are the classification of sensors like active sensors, passive sensors, contact sensors, contactless sensors, analog sensor, and digital sensors. So active sensors require power, okay, like ultrasonic. Passive sensors use environmental energy, okay, like camera, thermal sensor, microphone, and contact sensor. Contact and non-contact sensors like thermocouple, float level sensor, limit switch, and infrared thermometer, proximity sensor, ultrasonic sensor. These are the non-contact sensors. So contact sensors like need physical integration. Non-contact sensors like infrared work remotely. Analog versus digital, or we can also say digital versus analog. And analog sensors produce continuous signals, while digital sensors output binary data, means on and off. Okay, like this we can see how ultrasonic sensor works. It transmit data and reflect with an object and receive and then it detect an obstacle. This is a Arduino IDE, and this is a serial monitor. Okay, and we can the code on C++ language on Arduino IDE and upload them using this button. Okay, and when we click on serial monitor, we can see the output. Here we can use to select a port of using USB connect with computer. Okay, now we see the real world application example. Let's see how sensors and microcontroller work in my project. These are the photos you can see. This is the IoT system flow diagram. The sensors detect and collect the data and send to the microcontroller, and microcontroller process it and send to the communication via speaker or displaying, or send to the internet or messaging email. Now you can scan this QR code and see my portfolio. And to wrap up, sensors capture the world, microcontrollers process it, and IoT makes it smart and connected. Okay, that's all.